Well, good morning, good afternoon, good evening, everybody. This is Bruce Collins from Cambium Networks. I'm a Director of Product Management, and thank you for joining the webinar today. Today we're going to be talking about cnReach and how it applies to industrial applications. And I have a couple of brief case study examples of how cnReach is being deployed to save some operators money and improve their efficiency of their operations. And then I also will be going through in a little more detail the latest software release and hardware features that are available on cnReach. We just did a major software release called 0120 that was posted to our website last week. And I'd like to go through some of those features and make you all aware of what is there. So as a reminder, these webinars are recorded and they will be available on our website in the next day or so. You'll receive a email with a link to that recording. And at any time during the presentation, if you have questions, go ahead and put them in the webinar chat window, and I will take those as they come in. And certainly, I would expect plenty of time at the end, as the material here is probably about 25 or 30 minutes. So to give you a sense of how this will go. Without further ado, I will kick things off. So one of the things that we hear about and see with cnReach is that a large number of the applications are migrating from what we refer to as legacy SCADA systems or legacy wireless SCADA systems, and migrating those to a modern IP-based managed infrastructure system. And so what is a legacy wireless system? Here's a picture of one from one of our customers here in the US. What you can see here is a picture of a panel. Inside there is a radio, a PLC, some sensor interfaces, battery packs, a number of different devices there. And what they're able to do with that legacy system is it's serial-only communications. It's 9600 baud. You can see on that board there's some EEPROMs with handwritten paper labels. That means that's the way that the firmware or programming is updated on this PLC is actually burning EEPROMs and taking them out to the field. There's no ability to do remote management. There's specific vendor-specific protocols in play here, and then the hardware is just no longer being supported. So this is sort of the state of play that this customer approached us with and said, how do we migrate to something that's a little more maintainable? So what you'll see in this next slide is the after picture. So you can see from the size of this panel, it really is designed to fit exactly into that original panel. So it could have actually been reduced in space, but from a size perspective, the cabinet was already there, so they just replaced that entire panel. And you can see it's a lot cleaner look. There's fewer components, and the benefits that they're achieving with this view is standards-based IP communication, so it's all IP traffic. They've using cnMaestro for centralized network management. There's fewer devices. You'll see that in the upper right, you'll see sensors coming in to the radio itself, and that blue box is the cnReach radio. Coming into the top of that are the direct general purpose I/O connections. I'll talk about those in a bit more detail, but basically, because this is a fairly simple tank monitoring application, they were able to eliminate an external RTU. They also, in many cases, you can eliminate a Modbus TCP to Modbus RTU converter by the capability that's integrated in the radio. And then, ultimately, the radios themselves are a software-defined radio, so we can add different modulations, we can add higher capacity, and effectively, we get better efficient usage of the spectrum. And of course, it's capital efficient, as it's you're buying it once and you're not paying an operational expense because you're continuing to you just pay for the system once. So ultimately, the benefits: fewer truck rolls, faster response times, reduced outage times, the ability to manage this from a central location, meaning I don't have to drive a truck out there and check in on what's happening with the network. And then ultimately higher security, as you're able to monitor the system, see what's happening. If there's been any any change to the network so you can react to that. So how to get from that legacy to the modern one, there's really 4 ways that we'll talk about with cnReach that are fairly unique to the solution that Cambium brings. First is being able to eliminate extra devices. cnReach has that built-in general purpose I/O, so you have 8 pins, and you can define those as inputs or outputs. There's some variation amongst the pins, but effectively you can do analog inputs and outputs and digital inputs and outputs directly on the radio. And then you just pull the radio using Modbus to collect that information. We've also recently added this Modbus RTU to Modbus TCP conversion. So if you have an older PLC or RTU that only does serial communications, with the latest version of cnReach, there's a software converter built right into the unit. So oftentimes when customers do these migrations, without this feature, you would have to have an external box that does that conversion. There's a number of companies out there that sell these little boxes that would sit between the radio and the PLC. But by collapsing this and bringing this inside the radio, the software it eliminates that extra point of failure and the cost of that external device. Some of our customers are using cnReach to migrate from unlicensed ISM 900 megahertz band over to a licensed 900 megahertz band. cnReach has, in the 900 megahertz version, has both licensed and unlicensed capability, and it's just switched back and forth between a software configuration. So in cases where a customer has high noise floor, or they're concerned that that noise floor may rise in the future, the ability to switch on the fly to a licensed when those FCC license allocations are available, that makes that migration smoother. With cnReach, we can mix serial traffic with IP traffic, and this is very useful when you're migrating from the older systems that might have more latency sensitive or time sensitive data running on that serial interface. So we can mix traffic, serial traffic, using what we call seamless serial, which effectively takes away the headers and reduces the overhead and makes that serial communications go much more efficiently than if every single serial packet was put inside an IP, or every single serial data was put inside an IP packet and sent over the network. We've also introduced quality of service that allows the user, the network administrator, to prioritize that serial traffic. In general, by default, it goes out at highest priority ahead of management and IP traffic, but you now have the ability to adjust that quality of service. And that's in the new 0120 software release. And then, of course, the other way that people are migrating, and this is something that Cambium can bring to the table, is the ability to overlay broadband wireless with the narrowband. So you might overlay a 5 gigahertz PMP450i network, overlay that with your licensed traffic, and then use the broadband network for out-of-band management on the radios, and then also other things like remote office access, Wi-Fi access points, or even the video surveillance, for example, using the broadband out to the site. So you can kind of pair up and use the same management interface back at cnMaestro to do both a narrowband critical infrastructure monitoring application, and pair that up with, again, your video surveillance or remote access. So here's a little more detail on that particular customer in the first picture. This is a water tank application here in the U.S. In this case, what the customer is looking to do is, you can see that water tank in the lower left. They're looking to monitor the water level that's in that tank. And so they have a pressure sensor in there that's an analog input. They have an overflow sensor. So if there's a float, there's basically a float sensor at the top of the tank. If water starts to overflow, that will throw a digital input. They have a hatch cover to detect or know when someone has opened that hatch. There's a panel entry. So if somebody opens the control panel, that also triggers a digital input. And then finally, you'll see in the picture, middle of the bottom, the lower middle picture, there's a red button there. Customer or the technician on site can push that button if they need help, and it's sort of a quick alarm button that they can push or clear. That's another digital input. So what you'll see in the upper picture in the middle is the cnReach radio with those wires coming in the top. That's the sensors themselves. So this is a great example of the cnReach having the built-in general purpose I/O. So in this particular application, using the 5 inputs that they're looking for, they were able to put all of this right directly into the radio. No need for that RTU or external device to convert the sensor data, but it's all directly integrated. And then you'll just see the Ethernet connection that's being used for local management. Somebody was on site there. And then you'll see the antenna connection coming out of the bottom. And then in the picture on the right, going up to that Yagi antenna. In this particular application, these water tanks are all being serviced by a operations center in the center of the city. The typical distances are anywhere from 5 to 12 miles, 8 to 15 kilometers. And that's used, and if they need to go further than that, then they'll typically put in a relay node to go a little bit further. So great example of leveraging the capabilities of cnReach. This is a 900 megahertz unlicensed point-to-multipoint application, but it's a great example of leveraging some of the benefits of the product. Here's another example. This is also in the U.S. We have a case study on our website and that you can download and read more about this one. But this is a example of, again, of a water utility. And what they were really using here is the ability to migrate from unlicensed 900 megahertz to licensed 900 megahertz. So in this case, they were seeing some noise floor issues with their legacy system. They used Link Planner. You can see that in the lower left, sort of a snapshot of Link Planner, to plan the network, see what the capacity they could achieve in licensed and unlicensed. Again, Link Planner lets you select which band you're using. And then with the Link Planner release 4.8.1 that came out last week, we can now do point-to-multipoint planning with cnReach. And currently that's available just in 900 megahertz, but we'll be adding that point-to-multipoint capability in the other bands shortly in the next Link Planner release. So anyway, they planned it in Link Planner. They were able to deploy this network. The major benefits here are migrating to licensed 900 and then adding the ability to remotely monitor this using cnMaestro. And here's just another image of a radio in an enclosure, typical deployment. And in this case, there is an external PLC, and you can see how that the sensor wires come into the PLC, and then there's an Ethernet connection between the PLC and the cnReach radio. So just a visual example of another type of deployment that we see with cnReach. So I'm not going to go into a lot of detail on the product itself. There's other recordings of other webinars on the system if you want to learn more about the radios. But just as a refresher, cnReach can be deployed as a point-to-point topology, point-to-multipoint, and then you can see 2 different kinds of repeaters in the middle. You'll see a traditional store and forward repeater, and then a back-to-back repeater. And in the back-to-back repeater, you're actually leveraging the dual radio module with cnReach, and this is really the way to do repeaters with licensed spectrum. So if you're using IS or MAS bands in 900 or our bands in 450, 700, or 220, you can use that dual radio back-to-back repeater. And in this case, there's 2 radio modules, one in this case operating in the westbound direction, one operating in the eastbound direction, and you don't lose that capacity. So this is a very effective way of doing repeaters in a licensed spectrum. Again, if you have any questions, feel free to ask them on the chat window. We can take them as they go, just as a reminder. Link Planner, I talked about that before. Version 4.8.1 was posted last week, and it includes point-to-point support for cnReach on all the bands. So that's 900, 700, 450, and 220. It also includes point-to-multipoint for the 900 megahertz. So you can start to do multipoint planning as well. cnMaestro is available in beta for cnReach. If you have interest in having a look at how cnMaestro can help a cnReach network, please contact us and or your channel partner, and we can get you set up on that. We expect to have this fully released and integrated with the mainline cnMaestro by in the May timeframe, and that will also include the ability to do configuration push and pull, as well as some software and firmware updates over the air to the different radios. So a major release coming on that front on the cnMaestro side. So again, here's a brief summary of the product itself. It's available in those 4 bands. I'll talk about the latest hardware release, which is especially important for those of you joining from Europe, which is the 450 megahertz Oetzi radio. I believe I have a slide on that next. But cnReach is available in these 4 bands. We continue to expand that list. So again, if you're hearing from customers that have a particular interest in another piece of spectrum, please contact me and we can advise you on where that stacks up in the priority list. I won't go through this in a lot of detail, but again, we talked about the deployment flexibility, reliability. We test every one of these units 100% over temperature. So they're really designed for that rugged environment. So here's a real brief snapshot of the spec sheet for our new 450 megahertz Oetzi Red compliant radio. This is available now. This is a product that's in the 450 megahertz band and is geared towards deployments in the EMEA, Europe, Middle East, and Africa regions, as well as other parts of Asia and the CALA region that use the Oetzi standards. So this is a great upgrade to the radio for these Oetzi environments. The Red initiative went into effect, the final deadline was June of last year. We made some changes to the radio, and there's 2 major benefits here. One is this radio now covers 406 to 470 inclusive. So it covers that complete band from 406 to 470. You'll know that you'll remember in FCC bands, we cover 406 to 430 and 450 to 470. So there's that gap between 430 and 450. For this Oetzi radio, we've been able to close that gap and have one radio that covers the entire 406 to 470. We've also increased the transmit power. Previously, this was limited to 2 watts. With this new Oetzi Red compliant radio, it now does up to 8 watts. So this is significant for coverage and closing more difficult links through propagation. We have 12.5 kilohertz. Late breaking news on this one is we also are now supporting 25 kilohertz channels on this. That's typically the 2 channel sizes that are allowed in this band. So we have both 12.5 and 25 now approved through the regulators in the European Union. Other than that, it's very similar to the rest of the cnReach portfolio: 2 serial ports, 2 Ethernet ports. All of the other features that we've talked about are certainly built into this new Oetzi Red compliant radio. So let me summarize the new release. We have a software release called 0120 that's now available. It's posted on the website. There's a release notes. There's a user guide that takes you through the details on all of this. But I will summarize just the highlights here. The ones in yellow I have some slides on, so I'm going to skip over those, but those are key features: spectrum analyzer, quality of service, and what we call auto configure. We've also added some serial only modes. So if you, in particular cases where, again, you're doing serial only communications, you can put the radios into some serial only modes that make this system work even more efficiently when you're not having to mix Ethernet traffic into the network. And this can be useful for those migration scenarios. We have some a low power mode at 900 megahertz, so you can put the radio into a lower power mode. There's a Modbus RTU to TCP. We talked about this, which is the ability to eliminate that external conversion box. So built-in feature, and a number of customers have already taken advantage of this through our beta trials to eliminate an external device. Auto configure I'll talk about in a moment. There's been a number of security and usability enhancements. The usability enhancements are really targeted at eliminating or reducing mistakes in configuration. So the box will remind you if you try to make an invalid configuration, and it will just prevent in other cases if you try to set it up in a mode that would not be compatible with the other end of the link. And then on the security side, every release we do, we continue to monitor any potential vulnerabilities. We continue to upgrade different parts of the system and to continue to increase the security of the overall system. So Spectrum Analyzer, this is a great feature really for both unlicensed bands and also licensed bands. When you're in a licensed band, you don't expect to see any other traffic on that link or on that frequency, but it's sometimes useful in a troubleshooting scenario to see if that is in fact the case. So what we have here is a real-time spectrum analyzer. This can be run on any of the radios. It does take the radio out of service, so it's not a in service spectrum analyzer. When you put it in spectrum analyzer mode, it will start to listen and monitor and measure the noise floor at each frequency. But it does take the radio out of service. After a timeout, it will go back into service. So you can run this remotely if you're on site with an endpoint. You can also run it from an access point, but just keep in mind it will take the network down while you're doing this. In the upper right, you'll see a real-time spectrum analyzer view. So this is real-time view of the signal level at each frequency. There's some nice features. You can do a max hold. You can show a decay value. So you can set this up and let it run for a few minutes, and it'll tell you what's the maximum noise level or signal level that was reached at each frequency. That gives you kind of a rough idea of where's the signal coming from. And in this case, I'm scanning from the entire well, you can see here, this is scanning, look at the fine print here. This is scanning from 902 all the way up to 960. So this is covering, on the left side of that graph is the unlicensed spectrum, and on the right side is licensed MAS band. And you'll see those the two humps on the right are likely SCADA systems running on that particular channel, so you have that constant noise there. If you look in the lower right, there's a waterfall curve. That waterfall curve is effectively representing what's above, but it is over about, depending on the scan times, about a 10 to 20 minute period of what's happened in the past. And you can kind of pick out the red bars are showing when that signal was there all the time. And then if you look at to the right of that orange bar, you'll see it going yellow and then blue back and forth. That is likely a polling host, and it's while the signal level is high, it's actually coming and going, so it's likely a polling system in a SCADA environment. And then on the left side, you'll see frequency hopping, and you'll just you would expect to see the general noise floor from a ISM band. And that's what the charts on the left show, which is which frequencies are being used most often, and what is the overall power occupancy. So I can start to get a sense of the load that's on an ISM band, particularly in 900 megahertz. I can see how much of the time that band is being consumed by the transmitters that are in the area. So nice tool. It's all well documented in the user guide, and it's definitely worth having a look at. It's a great troubleshooting tool that we now have at our hands. Next feature is auto configure. This is really a significant improvement in the usability and maintainability of the system. The goal being to reduce stranded radios, reduce the time to configure new installs, and take the risk out of performance tuning. The way this works is you set the access points and the endpoints into auto configure mode. And then on the endpoint, I only have to put a few key parameters. I just have to put the IP address, the network ID, and the frequency. If I'm running in license band, I put the frequency that I'm authorized to run on. And if I'm in ISM band, I just put the 900 megahertz frequencies that I'm running my system in. So that's all you have to do. You don't have to worry about what modulations I'm enabling, the payload bytes, the uplink downlink ratios. You don't have to worry about network radius, hopping patterns. All those settings are just done once on the access point. And then as part of the access point's beacon that it sends out while endpoints are acquiring or locking onto the system, they can read in that beacon what the parameters of the network are. So the real benefit here is I can go in, let's say I have configured the network for a couple of the higher modulations like 16 QAM and QPSK. Now I want to go out and deploy a radio that is running at a farther out, and I want to put that radio in a lower modulation. I can just add that new modulation to the access point, deploy the new radio, and then all the other endpoints will automatically reconnect. Prior to this, you would have had to go out and make that change on every radio in the network and make sure that configuration change was complete, and then go make my change at the access point, which, as you can imagine, is prone to error and time consuming. So this is a major increase in usability of the system. So, and beta customers have been very happy with this feature so far. So it's been addresses one of the primary concerns people have with deploying this IP-based system. And then the last new feature I'll talk about, which is a hardware feature. This is our high availability 1+1 master station. This will be coming in second quarter. The goal with this product is to provide high availability for mission critical applications. This will reduce truck rolls. I can basically have two radios in the master station, and if the primary radio fails for whatever reason, whether it's a power supply issue, the radio itself, any kind of problem that radio has, the system will automatically detect that and swing over to the backup radio. That transition happens anywhere from a couple of seconds to, in some cases with large point-to-multipoint networks, it can take a few seconds. But the nice thing is you can have the system automatically come back online with the backup system, backup radio, and everything keeps running smoothly. You can then go do your maintenance at a more convenient time. You can set this up as either an access point, an endpoint, a relay, or point-to-point node, so it can really fit into any point in the architecture. It's available for all of the bands, licensed or unlicensed. We have the radios and the power supplies are hot swappable. You take that, this is meant to mount in a rack. It slides out on rails, and then you can take the lid off and hot swap those radios and power supplies as you do your maintenance. It's got that front panel LCD display, so I can see what's the status if I walk up to the device. I can also monitor this remotely. But on that front panel, I can see which one is active. I can, for maintenance purposes, I can swing it over to the backup. I can do a software upgrade on the primary, for example, and then swing it back into place. So a nice feature for those mission critical applications where you don't want to have any downtime due to either maintenance windows or any kind of failure of the radio itself. The other thing is the radio also monitors the communication. So it's not just power loss or not responsive on the radio. It's actually looking to see if historically I've had, say, 10 radios in my neighbor list. I've been talking to 10 different radios as an access point. If all of a sudden I'm not talking to any radios, then the assumption is that something has gone wrong. So it's a functional test as well as a physical test that the radio is operating correctly. So you get some nice analytics that go into that as well. So with that, just want to summarize. We talked about how customers are migrating from legacy SCADA systems over to modern systems. We talked about the new 450 megahertz Oetzi Red product, which is now available and shipping in regions outside of North America. We talked about the 0120 software release, which is now available and can be downloaded from the support website. And then the new hot standby 1+1 system, and as well as the link planner ability to do point-to-multipoint. So lots of things happening with cnReach. More to come soon as the team continues to build out and add features based on your feedback and input. If you do have questions or feedback on the product, you can reach me directly by email. You can see my email address at cambiumnetworks.com. I also invite you to visit our community, which is community.cambiumnetworks.com. This is a great resource for sharing information amongst peers, looking at examples of how people are deploying systems, but it's also a great place to ask those questions that might be difficult. It might be a very narrow niche type question that somebody on the support organization may be not as conversant in SCADA or those types of solutions. But if you lay out your issue on the community, not only will your peers jump in and help, but also our system engineers, our development engineers, our test engineers, product line managers are all online and available in monitoring the community. So great resource. Encourage you to take advantage of that as you go about your daily work. So with that, I'll wrap up. I don't see any questions. If you have any, please put them in now. Otherwise, look for an invite or a link to the recording of this message. And I will pause there a second, see if there's any last minute questions. Looks like we're good. Thanks everybody for joining, and we will talk again down the road.